Good afternoon, students. You follow the previous class? Previous recording? What you observed? Your ma'am is tell what concept? Some management concept, right? Did you observe anything apart from the concept? Any noise? Bangle sound? Putting the marker sound, isn't it? And one more thing, after recording that class, we observe, apart from the concept, the voice of a madam, we observed the sound of a bangle and other sounds. While our recorder, our sir records all the entire video, we observed first voice and other sounds. But when they played, we observed at a time all those signals, isn't it? Why is it looks nice? Is it looks nice? If you upload the same video into any of the YouTube channel, did you found that one? No, we won't observe. We observe a very clean video, isn't it? Only bass voice of the faculty and the content. Completely we focused on it. Is it how it happens? There our mathematics includes and the instruments. How? By introducing the Fourier concept and Fourier applications in those instruments, so that our curriculum included this Fourier series and Fourier analysis concepts for the BTech students, professional students, so that where the real life problems can be evaluated by those graduates and where the applications will be approved and applied. So today in this session we used to learn Fourier series and its real life applications. So first of all, what is this Fourier series? As a mathematical student, if I said if it is a Fourier series, just madam, you already know about that Fourier series definition. How? Madam, a periodic function will take a periodic function. Periodic function. What is a periodic function? Yes, we can write in the form of nt for all x and t is a positive value. Isn't it? We know the definition. Now we are taking such a periodic function. It is represented as an infinite series. That means a Fourier series is a representation, an infinite series representation of a periodic function into trigonometric series consisting the terms sine and cosine. Simply, a Fourier series is an infinite series representation of a periodic function which can be expressed in terms of trigonometric series. Madam, what it is? Can you write it in a mathematical form? It's not an easy way to understand and to remember, isn't it? So I'll tell you one thing. Remember, f of x is a periodic function, and you are writing this one of the form a naught by 2 plus sigma. As I said, it is an infinite series, so sigma n is equal to 1 to infinity, and the function can be represented in trigonometric series consisting of terms sine and cosine. So I'll write here a n cos n x plus b n sin n x. What is a n and what is b n? coefficients, we'll discuss it later. Where we are defining this one? In a particular region, in a particular interval. Let us take c and c plus 2 pi. In a particular region in the sense, suppose expansion. Madam, how to calculate these coefficients? Is there any formula? Yes, we have. That is a simple one. A naught is 1 by pi integral c2 c plus 2 pi f of x dx, and an 1 by pi integral c2 c plus 2 pi f of x cos nx dx, bn 1 by pi integral c2 c plus 2 pi f of x sin nx dx. This is the expansion of Fourier series for a periodic function. Now, where we use? First thing is in audio processing. Where? Audio processing. This relates with the example just now what I asked the first question. Did you hear the video of your madam? Next, image processing. This relates with the videographer and those who took the videos. And general real life, medical diagnostics. Next, what about us, madam? Electrical engineering, communications, what not. In many fields we are going to discuss this one. Machine monitoring. Let us see with this. While we record a video, it uses first this Fourier series, analyze each and every sound into different frequencies. It splits, it separates those signals according to their different frequency levels, and then it processes the repeated signals by using different techniques. With that, we use different softwares. For example, if I take audio processing, that is MP3 audio compression, one of the application. Can anyone say another one more? Mobiles. You are using mobiles. How we are utilizing? By putting headphones. What it happens there? You have to listen each and every pinpointed voice there. But are you? No. Without any disturbance, we are just focusing on the voice. There it includes Fourier series by giving different values to these coefficients, by raising this n and by decreasing this n, by reducing or by increasing or by completely minimizing. We are using this Fourier analysis, Fourier series and Fourier transform techniques in your real life application. So, in a similar manner, we adopted this technique to image processing by giving complete image details, medical diagnostics, that means for example ECG, MRI, CT scans and everything, and the remaining 3 fields where we use these Fourier series analysis in these domains. You have to find out the example in the next session. Okay, so finally we concluded that this Fourier series, what it takes, it analyzes the complex attributes or complex signals into simple form of sine and cosine terms, okay, which was very much useful to our real life applications. Is it clear? So, can you read out this definition? Right, so by reading out, we can easily understand. Thank you. Thank you.